Okay, for further calculation, we need to define the formula for that for operations, additive, subtraction, multiplication, and division. And if you look at this formula in this way, then it is a little bit complicated, right? But we already have that P over Q is the representative of these equivalence classes. Okay, so when you look at the left hand side, that's just same as P over Q, like a plus minus, right? And R over S. And the usual technique for that is making common denominator, which means we have to multiply S for the numerator and denominator of the first term, and multiplying Q for the numerator and the denominator of the second term. And if it's plus, then plus. If it's minus, then it's minus for the numerator only, right? Then in this notation, let's just read, because this is just addition or subtraction of two integers, because PS, QRs are all integers. So it's just same as PS plus minus QR, comma, QS. Like that, right? And that's the definition over here. So you can see all these formulas in here, it's just kind of the translation of our traditional addition, subtraction, and multiplication and division in this new format, new way of it, right? So it's no problem with that, right? So product, so P over Q times R over S. The typical format was PR over QS, right? That's exactly representing these equivalence classes. And the division, PQ divided by RS. And actually divide by means, division means P over Q times multiplying the reciprocal of it, which is S over R. Then following this product, we have PS over QR, and that's here. Okay? It looks like we're multiplying the opposite side, the far side, and put inner ones for denominator like that, right? But same thing. Okay? And when we do this, the condition for that the division is naturally QS cannot be 0, right? But when you do this portion, R becomes like part of it, right? For the denominator of the result. So we cannot do this. So technically it was should like QR cannot be 0. But Q already cannot be 0. So the only case is when R becomes 0, right? So this is enough to state here. But the real meaning is the resulting quotient form cannot have 0 for its denominator. That's all, right? Okay, so let's just try to calculate it. So what is 3 over 5? I will represent it for that. It representing for this equivalence class 3, 5, right? And 5/3 is representing 5, 3. So 3/5 plus 5/3 is sum of these two, and according to our definition, we need to multiply the outside ones, right? P and S. So it's 3 times 3, and it's addition, so it's plus inner ones Q and R, right? So 5 times 5 for the first term, and the second term is just multiplying the second terms only, right? So it's going to be 5 times 3. So altogether, it's 9 plus 25, 15. So it must be 34, 15, right? So we can say it's 34, 15, and there is no cancellation, right? So this is good notation for the result, and that's what we usually have, right? Okay, then go to the next one. Let's check this result. There are two equalities. The last one, it must be same as this because we proved this one in the previous video, right? Like negative p over q is p over negative q, right? So because of that, that is it's clear. So all we need is these two equalities, right? So first one, before doing that, let's just find out the 3/5 is 3n 5 and 5 negative third, because in this notation we could use integers, so we can put this negative there. Okay, so let's just adding this one. Then it's 3, 5 and 5 negative 3. So the outer one is 3 times negative 3 plus 5 times 5 comma 5 times negative 3. So that is negative 9 plus 25 comma negative 15. So it's 16 comma negative 15. So the result is 16 over negative 15, but because of that one before, we can change this one to negative 16 over 15, which can be here, right? So we show that. The next one is subtraction. So let's just check this. Then the difference is just the negatives, right? Over here, if it's negative, and it's negative only there, right? So it has negative. So let's just use that. Then negative 34 comma negative 15. Oops, okay, I made a mistake, sorry. It's not subtracting 5 over negative, it's just 5 third, right? Of course, because this result doesn't look like the same as the previous one, okay? Sorry, so let me redo it again. 3/5 minus 5 third only, so let me do that. 35 minus just 5 3, okay? So it's 3 times 3, in this case minus, right? Minus 5 5 comma 5 times 3, right? So it's 9 minus 25 comma 15, and that's negative 16 comma 15, and that is negative 16 over 15, right? Same as this one. So that's the whole proof. Okay, so this example is just similar and maybe easier than additive or subtractive. Okay, so please do and find by yourself for this one. Let me skip that one for your practice question. Okay, let's look at the next case. Now let's show 0, which is representing that equivalence class 0 comma q. We don't need to say this by the definition, it's clear, right? Q cannot be 0, but I want to just emphasize that. Then 0 must be additive identity, which means if we add 0 to any rational number, it just returns that rational number itself. Okay? And of course, that is also true for the other direction like that, right? But let's just do that. What is P over R? In our notation is P comma R. Okay, and 0 So it's representing 0, q, and that q can be any integer except 0, right? Everything is okay. So let's just add these two numbers. Then we are adding these two rational numbers, really. And according to our definition of addition, we need to multiply the outer parts plus inner terms and the y coordinates, or y coordinates, right? Then that is same as pq comma rq, right? Because that is 0. So it's same as pq over rq, which is good way to look at it. But if we make it, okay, the list forms of it, then it's going to be p of r. We got exact same results. And please show the other part by yourself. So by that, we can claim that 0, or that equivalence class, is the additive identity. Then we can just do the similar procedure for 1, which is just q comma q, or the simplest form of that is just 1 comma 1. So for this case, maybe that is better and easier, right? And more reasonable. Okay? Of course, if you look at just as a natural way, the general way, then we have to put q comma q, and in this case q cannot be 0, right? But the same thing. So for the proof, let me just use this one. I can choose any representative, right, for that entire equivalence class. So 1 comma 1 is reasonable. So let's say p of r is representing p comma r, that equivalence class is, and 1 is just 1 comma 1. Let's say that. Then p of r times 1 is p comma r times 1 comma 1. Then according to our definition of product is x coordinates and y coordinates, which is p comma r, which is p of r. Okay? And please do the other part, right? So 1 times p of r is also same thing, right? So which means 1 is the multiplicative identity. Okay, so when you do your homework, yep, the other parts are okay, and this is the missing parts, right? Okay, so please prove by yourself that it's doable. So the other parts are just similar to the others, right? So when you do this, you are going to get some equivalence classes whose representative must be negative, right? So please do that. But the number 6 is just for fun. Okay? Look at the notations. The ordered pairs with the parentheses, and that is for integers, right? So instead of giving you like 2, 7, whatever, I give you the notation for 2 in our way, which covered in previous chapter, right? So, okay, you know what, right? So like this, right? Okay, so it can be any number, like 1, 3 is also possible, 2, 4 is possible. So among all these infinitely many different choices, I just choose 1, right? And for that, so your task is, what was the definition of that integer? It's as it is, right? So it's going to be much easier if you translate this one to, oh, it's 2, 3 is 1, right? And 7, 5 is negative 2, right? And take division. It's simple. It's really doable. I'm not interested about it. You did much more general cases like that, right? So, but keep that form as it is, right? So do not change 2, 3 to 1. Okay? Just use 2 comma 3 as it is, and please perform this calculation. Okay? So instead of 1, you have to use 2 comma 3, right? So you don't have that nice symbol. You only have that meanings of it. Technically it should be like this, right? But there are too many brackets and like this, so I just kind of skip that portion, right? So please imagine that is not just a simple point, right? It's equivalence classes, but same as that number, right? Okay. So when you do this, for example, especially like when you have to take the division first, right? But you have to calculate this. But when you calculate it, for example, let's assuming that we only have this subtraction, then what you're supposed to do is, because of the subtraction, the result must looks like this outer one first, right? So you need to multiply this one times this, right? Then what was the definition of that product, right? In that integer part, right? You have to apply that rule here. Okay? So please perform the combination of these all definitions, right? All together. Okay? And once again, yes, we have much better way and simpler way to do that. This is only just for practicing, right? Those kind of definitions again, right? And at this moment, it's really combination of these 2 chapters together. Okay, so you know what I mean, right? So that's the end of chapter 20.